Have you ever seen those health headlines that seem to contradict each other every other week? One day coffee is a superfood, the next it's terrible for you. So what's the real story? Well, a lot of the time, the answer is hiding in the numbers. Today, we're going to pull back that curtain and demystify the statistics that shape everything we think we know about our health, so you can make sense of it all.
Okay, so let's just dive right in. You might think statistics is some boring thing for labs and spreadsheets, but it's actually way more like a casino. The house always has an edge, right? That's because it knows the odds, down to the decimal point. Well, in a way, your health is kind of like that too. In statistics, that's just the science of understanding those odds, whether you're at a blackjack table or in a doctor's office.
And it is everywhere, not just in casinos. I mean, think about it. That route Google Maps just suggested for your commute, that's statistics predicting traffic patterns. The ads that pop up in your Instagram feed, yep, that's statistics too, analyzing what you're likely to click on. It's kind of like the invisible engine that runs our modern world.
So, here's our game plan for today. First, we'll see just how much stats are all around us. Then, we're going to give you a basic toolkit, just the essentials. After that, we'll put those tools to the test on some actual medical data. We'll even talk about how scientists can take a small study and make big conclusions. And, by the end, you'll walk away seeing data in a whole new light.
All right, let's get to the heart of why we're really here. And let me be clear. This is not about turning you into a math genius or making you memorize a bunch of formulas. It's about something way more useful. It's about helping you become an intelligent consumer of information.
I just love how this is phrased. The goal is to make you an intelligent consumer of science. That's it. It's all about giving you the confidence to look at a study or a news report and ask the right questions without ever needing to pull out a calculator.
And to do that, you just need a few key tools. Think of this next part as your Statistics 101 starter pack. These are the absolute essential concepts that are going to unlock everything else for you.
So, the specific field we're diving into is called biostatistics. It sounds fancy, but really, it's simple. It's just what we call it when we take all these powerful statistical tools and apply them to questions about medicine, health, and biology. It's how we figure out if a new drug actually works or spot patterns in a disease outbreak. Now, this slide here shows one of the most fundamental ideas in all of statistics. See, it's pretty much impossible to study everyone, the entire population. I mean, think of a giant football stadium. You can't possibly interview every single fan. So what do? You take a sample. You go to one section and talk to those fans. And then you use their answers to make a really good, educated guess about what the entire stadium is thinking.
Okay, let's make this feel real. Imagine you're a medical student, and you're getting points for your work in a clinic each week. And you're doing great. You're getting scores like 9, 8.5, 9.5, and then, 1 week, through no fault of your own, a patient just doesn't show up. And you get a 0. Uh-oh. That one single number is about to cause a bit of a problem.
So if you calculate the mean, which is just the plain old average, your score comes out to 7.7. But that single 0, that one unlucky week, acts like a giant weight. It just drags the whole average down. In fact, without that 0, your average would have been a much more accurate 8.3. This is a perfect example of how one extreme value, an outlier, can totally mess with the average.
And this is exactly why we also have something called the median. The median is super simple. It's just the middle number if you line up all your scores from smallest to largest. For our student, the median is 8.25, which is a much, much fairer picture of their performance, right? The median just isn't bothered by that one weird 0. So, the big takeaway here? Anytime you see the word average, your first question should be, I wonder if there's an outlier that's skewing the story.
Okay, tool belt is on. We get the difference between a population and a sample, and we know to be skeptical of the mean versus the median. So now, let's actually put these brand new tools to work on some real medical data. This is the big question, isn't it? It's like, okay, cool, I get these simple ideas, but how in the world does this help me understand those super complicated health reports I see online? Well, let's find out.
Whoa, okay, at first glance, a table like this from a real medical study can feel like a lot. It's just a wall of numbers. But I promise you, you already have the basic skills to start making sense of this. We just have to break it down piece by piece.
So let's ignore everything else and just zoom in on one single number from that table. 262,612. It's a big number, but what on earth does it mean?
That number, that's the total number of times someone went to the emergency room for a dental problem in Massachusetts over a 5-year period.
Just by finding that one total number, we immediately get a sense of the scale of this problem. Over 250,000 visits, that tells us this is a pretty significant issue.
Now let's grab another piece of data. Here's the breakdown by sex. We can see it was about 52% male and just under 48% female. The second you visualize that as a simple bar chart, the data becomes way easier to understand. See? We've only pulled out 2 data points, and we're already starting to get the big picture.
All right, now we're going to level up. Remember how we talked about using a small sample to understand a huge population? Well, this is where it gets really cool, because this next part is all about how scientists deal with the uncertainty that comes with making that leap. But here's the catch. Imagine you have a giant jar of marbles, and exactly half are red and half are blue. If you reach in and grab a handful, your sample, you might get 6 red and 4 blue. If your friend grabs a handful, they might get 5 and 5. Every sample is going to be a little bit different. So how do scientists deal with that randomness? Well, the answer is they actually embrace the uncertainty. They use this really clever tool called a confidence interval. So instead of a headline saying the average height is 5'9", a scientist will say something like, we are 95% confident that the true average height is somewhere between 5'8" and 5'10". It's their way of being really honest and precise about their level of uncertainty.
So what makes that range of uncertainty get bigger or smaller? It's mainly 2 things. First, the size of your sample. It makes sense, right? The more people you study, the more confident you are in your result, and the smaller or narrower your range of error gets. Second, how much the data varies. If you're measuring the height of pro basketball players, they're all pretty tall, so your range will be narrow. But if you measure the height of everyone in a city, the data is all over the place, and your range will be much wider. This is a huge insight. If you see a study with a really wide confidence interval, that could be a red flag that their results aren't nearly as solid as the headline makes them sound.
Okay, we have covered a ton of ground here, from the simple mean and median all the way up to confidence intervals. So let's bring it all home and talk about our final empowered takeaway. So let's recap the big ideas. First, always question the average. Is there an outlier hiding in there? Second, remember that a sample is just a snapshot. It's not the whole movie. Third, look for that confidence interval. It's actually a sign of good, honest science. And finally, and most importantly, remember the goal here isn't complex calculation. It's just critical thinking. So here is my challenge to you. The very next time you see a health study in the news, don't just read the headline and move on. Ask a question. I wonder how big their sample was. Or are they talking about the mean or the median? That's not being cynical, that's being a smart, empowered consumer of science. And trust me, that is a skill that will serve you for the rest of your life.